Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Number 17, got orientation factor. Okay, so um, an orientation factor talks about the specificity of your molecules in terms of the orientation from the word itself, orientation. Okay, so what I mean by that is if you have um, two molecules reacting, so let's say you have blue and a green one, and then you have, let's probably just use the same colors. Okay, so these molecules are going to collide in different ways each time. Okay, so the orientation factor is the fraction of the orientation that would allow for the reaction to happen. So let's say if you got again, if you had this molecule and your second molecule would approach it this way, right? Versus this first one where it's face to face. This one it's kind of on approaching from the bottom. And as you could imagine, there's so many ways that these molecules could approach each other, right? Maybe this time the blue one would be flipped. It would be at the bottom and then the green one would be on top. Okay? So let's say um, let's say this first one is going to allow for the reaction to happen, and the second one, this one would also allow for the reaction to happen, and this one would not, right? So your orientation factor would be 2 out of 3, which is 0.66, right? Or 0.67. Anywho, so that's your orientation factor. It's the fraction of possibilities that would allow for the reaction to happen. So as you could probably tell by now, the higher your orientation fraction or orientation factor is, which is um, denoted by P. So the higher your P is, the higher your rate is. Okay, so that's it for orientation factor in the collision model. Hopefully that information was useful.